Hi, Notion. Mm-hmm. I am fine. I am doing good. Soon I'll start. Okay, hi everyone. Welcome to the class student the brand. This is your Shiva sir from Sumaya. How are you? Welcome to the class. So we can go with the. Today we are going to discuss about human and colorful world. CBSE Grade-10 Physics. Human and colorful world. Human and colorful world. Human eye and colorful world. Human eye. Human eye and colorful world. Human eye and colorful world. Colorful world. So CBSE grade 10 physics. So here, oh, thank you so much. CBSE grade 10 physics, CBSE grade 10 physics, CBSE grade 10 physics. Now we are going to discuss about myopia, myopia, myopia. Myopia, myopia, myopia. For that correction we are using myopia, 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 myopia. Near distance we can see far distance we can see myopia, 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 myopia. Near distance we can see Far distance we can see myopia, 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 myopia. For that correction we are using. Bro, what bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, hypermetropia. For that correction, we are using convex lens, convex lens, convex lens. Hypermetropia, hypermetropia, convex lens, hypermetropia, convex lens, hypermetropia, concave lens. Concave lens, myopia, concave lens, myopia. So that is about. So we are going to discuss about human eye and colorful world. Human eye and colorful world. Now we will discuss human eye and colorful world. So here, especially if you close your eyes, okay. So if you are close your eyes, you can't see anything. So once you open your eyes, you can able to see everything in front of us. Yes or no? So eye is the most sensible and sensitive organ in our human body. So now today we will discuss about human eye parts and function. Today we are going to discuss about human eye parts and function. So ready? So be ready for that. So I'm taking now. So drawing the diagram, how to draw the diagram? How to draw the diagram? So I'm telling. So just to draw the circular, okay, just to draw the circle. So you can draw like this. First step. Wow, perfect circle. Excellent. Nice. Okay. So now you are considering. Now you are considering. Now you are considering. Now here I'm considering. Okay. So here I'm taking. Here also I'm considering. Right. Now you can see this is about cornea. 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 I'm considering here cornea. This is a cornea. And so this is islands. 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 So I'm considering here. So now you can see here, now you can observe human eye parts and function, human eye parts and function. So I'm considering here, I'm considering the front portion is the cornea, so the front portion protect the layer of the eye. So most of the refraction takes place. The front portion protect the layer of the eye. Most of the refraction takes place at this part. And so we can consider ciliary muscles. Ciliary muscles are the no, so ciliary muscles which hold the lens, which hold the lens. So whenever we want to see the nearby object and far object, so I'm considering here. So this is a convex lens. When we want to see the nearby object, far object, when you are seeing the nearby object, eye lens will be thick, focal length decreases, focal length decreases. So when you are seeing the far distance object, when you are seeing the far distance object, eye lens become thin, eye lens become thin, eye lens is the convex lens become thin. So focal length increases, focal length increases, focal length increases. By that reason, by that we can able to see far distance object also. By that we can able to see far distance object. So if you are seeing the nearby object, if you are seeing the nearby object, the convex lens thickness will be, convex lens thickness will be increases, focal length decreases. By that we can able to see near distance object. When you are seeing the far distance object, so eye lens curvature will reduces, eye lens will become thin, focal length increases. So by that we can able to see far distance object, far distance object. This is a convex lens. This is convex lens. Yes or no? You can see here in the eye also there is a convex lens. So this is the convex lens. So it will be there. So convex lens. Okay, whenever you are seeing the nearby object, far object, this ciliary muscle. So it will be holding like this. By holding like this, whenever we are seeing the nearby object, far object, so it will be holding, and so according to the thickness of the, so curvature of the eye lens increases or reduces, it adjusts by seeing the nearby object as well as far object. Ciliary muscles, it holds the lens like this. So here you can observe, here you can observe. So that is about ciliary muscles. That is about ciliary muscles. Now you can see your iris. Iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm which controls the size of the pupil. Iris is a dark muscular diaphragm which controls the size of the pupil. People will control and regulate the amount of light entering into the eye. People will control and regulate the amount of light entering into the eye. So aqueous humor is a jelly type liquid present between the humor is a jelly type liquid present between cornea and eye lens. Aqueous humor is a jelly type liquid present between cornea and eye lens. So it gives the blood and nutrition to the central cornea. Coming to the vitreous humor. Vitreous humor is a yes. So people, iris and ciliary muscles and eye lens is there. Eye lens is a convex lens. When a light ray falls on it, it makes the light rays to converge and falls at retina. Vitreous humor, this entire portion is filled by the vitreous humor, jelly type liquid present between, jelly type liquid is present between, jelly type liquid is present between eye lens and god, eye lens and retina, eye lens and retina, eye lens and retina, jelly type liquid present between eye lens and retina, eye lens and retina. That is vitreous humor. That is vitreous humor. So it provides sufficient force and pressure to maintain that shape. Coming to the retina. Retina is a light sensitive screen where image will form. Their image will form. Light rays will meet at retina. So image will form. What type of image will form? What type of image will form? Inverted and real image. Inverted and real image. Inverted and real image. Inverted and real image. Coming to rods. Rod sense the intensity of the light. Cone sense the color of the light. Rod sense the intensity of light. Cone sense the color of the light. So optic nerve, optic nerve, optic nerve, optic nerve. So whatever the image is forming at retina, that will be converted into electrical signal that will pass to the brain through optic nerve. Optic nerve is the nerve which carries the electrical signals to the brain. Whatever we are seeing, that is 2D image. Whatever we are seeing, the 2D image. Okay, so that image will reach to the brain. So in the form of electrical signals, brain will add the additional information. Brain will add the additional information. How much depth the water is filled, how much height the water is filled, how much distance it is. 3D information brain will give. So brain will give the 3D information. Yes or no? So this is about human eye, parts and function. Once again, cornea. Cornea is a frontal layer, protective layer of the eye. Most of the refraction takes place at cornea, and so we can consider here. So cornea and ciliary muscles which adjust the curvature of the eyelids. So to see the nearby object as well as far object. Iris a dark muscular diaphragm which controls the size of the pupil, and people will control the amount of light entering into the eye. People will control the amount of light entering into the eye. So that is about people. And aqueous humor is a jelly type liquid present between cornea and eyelids. Aqueous humor is a jelly type liquid present between cornea and eyelids. So this is about, and here this entire portion is filled by the vitreous humor. The entire portion is filled by the vitreous humor. Vitreous humor. So it gives the sufficient force and pressure to maintain that shape. Retina is the light sensitive screen where image will form. So there, that point, okay, that is the retina, ideal light sensitive screen. So in that place, image will form. That is what type of image will form? Inverted and real image. Inverted and real image. So there at retina, rods and cones are present. Rod sense the intensity of the light, cone sense the color of the light. Rod sense the intensity of the light, cone sense the color of the light. So whatever the image is forming at retina, that will be converted into electrical signal that will pass to the brain through optic nerve. Optic nerve will carry the electrical signals to the brain. Yes or no? So whatever the image is forming, that we are seeing the 2D information, brain will add the additional information. Brain will add the additional information that it will give 3D information. This is about human eye, parts and function. Next, we are going to the myopia. Myopia. Near distance we can see far distance we can see myopia. For that correction we are using for that correction we are using bro. What, bro? For that correction we are using concave lens. Concave lens. Myopia. Near distance We can see a far a distance. We can see a myopia, myopia, myopia. For that correction, we are using, we are using. Bro, what bro? For that correction, we are using, we are using concave lens, oh, concave lens, oh, concave lens, oh, concave lens, oh. Thank you so much for joining and listening. So, yes. So near point is nothing but the minimum distance up to which a person can able to see clearly. The minimum distance up to which a person can able to see clearly without any strain is called near point. Near point is 25 centimeter. That is also called least distance of distance vision. Least distance of distance vision is nothing but so up to a certain can able to see clearly without any strain or pain, that is called least distance of distance vision, that's a 25 centimeters. So below that the person can't able to see, more than that only he can able to see. Okay, so we can see maximum point or far point, the maximum distance up to which a person can able to see clearly without any strain or pain, that is called maximum distance. So that is nothing but maximum point or far point. So far point, near point. So far point is nothing but maximum distance up to which a person can able to see clearly without any strain or pain, that is called or least distance see the object without any strain or pain, that is called far point. Far point is infinity. Far point is infinity. Near point is 25 centimeter. Far point is infinity. Near point is 25 centimeter. Far point is infinity. So I am considering here 25 centimeter is a near point. So far point infinity. The person who has myopia, in the song itself it is there. The person who has myopia can able to see clearly up to certain limit, that is near point, near up to certain limit, and so more than 25 centimeter, so up to certain limit he can see clearly, right? So far point he can't see, so far point he can't able to see, far point he can't able to see, far point he can't able to see. Okay, so far point he can't able to see, only he can able to see, only he can able to see, only he can able to see near point, only he can at up to certain distance, up to certain distance only he can see, but he can't see the far point. So here, so I already said up to certain distance, yes or no, up to certain distance he can see near point, but up to certain distance only he can see, right? Yes or no? So between this point he can see, between 25 to infinity he can see, that point is called, far point of myopic person, far point of myopic person, far point of myopic person. Okay, so that point, as I said, if the light rays are coming from this point, he can able to see. Anyway, 25 he can see, so leave it about it. So far point, so until certain limit only he can see. That is called far point. So this point he can't able to see. This point he can't able to see. So we need to correct the defect. We need to correct the defect. So those three diagrams you draw, that's enough. Point number one, far point. Point number two, where the light rays are coming from infinity, how it will be. And the third one is correction. Those three diagrams I will draw. Those three diagrams I will draw. You can see those three diagrams. Those three diagrams I'll draw. Listen, observe carefully. See, while drawing the diagram, you must observe carefully. So while drawing, how I am drawing, that is very, very important. Okay. So follow me. So just check once how I am drawing. So take this one. Okay. So here optic nerve is not required while drawing the defects. Optic nerve is not required. Just you can take a eye. So here I'm considering. So this is the lens. Lens. This is the lens. Okay. And I'm considering light rays. I'm considering. Okay. You understand the diagram. You need to understand the diagram. This is the near point. Near point. This is the far point. As I said, this point, far point of myopic eye. If the light rays are coming from this point, so those light rays will meet at retina. As I said, the person can able to see clearly this point. If the light rays are coming from this point, from our point, he can able to see. He can able to see. So I am drawing. You can observe here. I am taking the light rays here. You can use pen, scale, pencil, eraser. Then it's very easy to you. You can draw. Like this. And if you want to get neat and clear image, clear diagram, arrow marks make it in a single line. Like so, to get uniformity, you can draw on single line like this. So if you are drawing like here, okay, you can follow here only. Then you will get it. So incident ray, refracted ray for that. Actually, this myopia, hypermetropia, these are all refractive defects because so proper refraction does not takes place. If the light rays are coming, so if lens refract the light ray properly, there won't be any defect. Because if the light rays are coming from this point, the lens won't refract properly. That is the reason. So next diagram you can observe. Next diagram. Next diagram. So this is the near point, as I said. This is the far point of myopic eye. So I'm considering here again near point, and this is a far point. If the light rays are coming from infinity, you can't able to see. So I will draw the diagram. Just check once. So this dotted line represent. This dotted line represent. So light rays are coming from infinity. So here you can observe. For uniformity, you can take all the lines, all the arrow marks in one line like this, and here also, and here also. So here, as I said, if the lens refract the light rays properly and make it falls at retina, then there won't be any defect because lens won't refract properly. So due to aging, so it happens. So myopia, so can't able to see far distance, he can able to see near distance. So because of this one, short focal length, he can see near distance, he can't see the infinity point. Yes or no? So this the see if you see the second diagram only, causes also you'll get. I will explain causes later. First focus on diagram. So I am taking F. So this is a far point. This light rays. Dotted lines represent. Dotted lines represent. Dotted lines represent. Dotted lines represent light rays are coming from infinity. Dotted lines represent light rays are coming from infinity. So correction. What lines we are using to correct the defect? What lines we are using to correct the defect? We are using to correct the defect of hypermetropia. Yes or no? Hypermetropia. We are using, sorry, concave lens. We are using concave lens to correct the defect of myopia. We are using concave lens to correct the defect of, we are using concave lens to correct the defect of myopia. So what lens we have to use? Concave lens. I'm placing a concave lens. So this is a concave lens. You can observe. This is a concave lens. Okay. So like this you can take. Fine. So near point and this is a far point. Okay. So if the light rays are coming from infinity, so I'm taking the light rays. So because it's a diverging lens. It's a diverging lens. If you want to show the nature of the diverging lens, you can take the paraxial rays, the rays which are very close to the principal axis. Anyway, after that, if it passes through the convex lens, again it will converge. So no problem. You can take paraxial rays. Take paraxial rays. It will. So you can able. We can show the diverging nature. We can show the diverging nature. Okay. So arrow marks. Take care about arrow marks. It must be in single line like this. So if you make it all lines one line also fine. That is your wish. But inside of the diagram, you must draw the same lines. Okay. So now I'm considering. So this is a near point, far point. So we are taking the dotted lines. So once observe the diagram, you can check the diagram once. So if you are drawing here, so these these light rays should meet at far point. Okay. Okay. So these light rays should meet here. Then we can understand. Okay. So I hope it is very clear. Once observe the diagram. Observe the diagram. So as I said, first one you can consider. First one. So near 25 centimeter, you can see this is a far point. This is a far point of myopic eye, far point of myopic eye. Okay. So this is a far point of myopic eye. So from light rays are coming from this point. Light rays are coming from this point. So those light rays will meet at retina. So this point you can able to see. Second point, if the light rays are coming from infinity, so light rays are coming from infinity, we can't able to see. Light rays will meet in front of the retina. And so to correct the defect, we are using concave lens. We are using concave lens. We are using concave lens. Yes or no? Yes. So done. Now you can take. Now see. I'll write the points. I'll write the points. So this is far point of myopic eye. Far point of myopic eye. Myopic eye. And this one is far point of myopic eye. Far point of myopic eye. This is the myopic eye. Myopic eye. Myopic eye. And this one is, what is this one? What is correction of myopia? Correction of myopia. Correction of myopia. Correction of myopia. Right? So check once. So here to remember, so don't get confused between lens. So concave lens, we are using concave lens. So keep in mind, we are using concave lens to correct the defect of myopia. To correct the defect of myopia, we are using to correct the defect of myopia, we are using concave lens. Concave lens. Is it clear? Check once now. So take 2 minutes, observe the diagram. Next one, we are going to discuss about hypermetropia. So next one, you have to draw the diagram. So hypermetropia means we can see far distance, we can't see near distance. Hypermetropia means we can see far distance, we can't see the near distance. For that correction, we are using convex lens. Convex lens. Hypermetropia. 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 Far a distance we can see. Near distance we can see. Hypermetropia. Hypermetropia. For that correction, we are using convex lens. Convex lens. Convex lens. Convex lens. Hypermetropia. Convex lens. Hypermetropia. Convex lens. So that is about hypermetropia. So we can see far distance. We can see far distance. We can't see near distance. We can see far point. We can see near point. For that correction. We are using convex lens. Convex lens. Convex lens. So You can observe, I'm taking here, I'm considering here, okay, so far distance object, this is infinity, we can able to see infinity point, we can't see the near point, we can able to see the near infinity point. So we can able to see near far point, we can't see the near point. For that correction, see somewhere between you can see, somewhere between infinity and 25 centimeter you can see, that is the near point of hypermetropic eye, near point of hypermetropic eye, near point of hypermetropic eye, hypermetropic eye, hypermetropic eye. Far a distance, we can see, near distance, we can see, but near point, somewhere between infinity to 25 centimeter, you can see that is near point of hypermetropic eye. Now you can see here, I'm taking now. So draw the diagram carefully, practice the diagram effectively, then you'll get proper marks. Subject, try to learn the subject. So if the light rays are coming from 25 centimeter, what happens? We'll see. Light rays will meet beyond 25 centimeter. So I'm taking this is the n. This is the n dash. So for the correction, we are using convex lens. Convex lens. can draw the So now you can observe here. Now we can observe. So this is a convex lens. Convex lens. Okay. Convex lens. Now, so first one is you can. This is near point of hypermetropic eye. Near point of hypermetropic eye. Hypermetropic eye. So this one hypermetropic eye. Hypermetropic eye. Hypermetropic eye. This is a correction of hypermetropic eye. Correction of hypermetropic eye. Correction of hypermetropic eye. Okay. So now you can observe. Now we can observe light rays are coming from near point. You can light rays will meet at retina. If the light rays are coming from near point, so light rays are coming from near point. You can so the light rays will meet at retina. Okay. So here you can see if the light rays are coming from here, the light rays will meet beyond retina. Beyond retina. The light rays will meet beyond retina. Okay. So here you can see correction of hypermetropic eye. If the light rays are coming from N, the light rays will meet at retina. The light rays will meet at retina. So the light rays will meet at retina. So if you are extending, the light rays will form at N dash. N dash. I hope it is very clear to you all. So this is about hypermetropia, 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 hypermetropia. Far a distance we can see, near distance we can see. Far a distance we can see, near distance we can see. For that correction, for that correction, we are using, we are using convex lens, convex lens, convex lens. So that is about hypermetropia. So we can see far distance. We can't see the near distance. Somewhere between infinity and 25 we can see. That's the near point of hypermetropic eye. So by seeing this one, so eyeball becomes small, focal length increases. Those are the causes of hypermetropia. Eyeball is small, focal length is large. So due to that reason, so we can't able to see. For the correction, we are using convex lens. Convex lens. Dun, 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 dun. Mm-hmm. Hypermetropia. 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 Mm-hmm. 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 So if the light ray passing through the prism, if the light ray passing through the prism, okay, so it's split into seven colors. It's split into seven colors. Those are violet, indigo, blue, green, yellow, orange, red. Seven colors. Violet, indigo, blue, green, yellow, orange, red. VIBGR. So here, Splitting a white light into 7 colors is known as splitting a white light into 7 colors is known as dispersion. Splitting a white light into 7 colors is known as dispersion. Those 7 colors will form like a band on the screen. Those 7 colors will form like a band on the screen that is called a spectrum. Spectrum. Splitting a white light into 7 colors is known as dispersion. Those 7 colors will form like a band on the screen is called spectrum. Spectrum. Okay. So now you can see. Actually, when Newton sent the white light ray, it split into 7 colors. So those 7 colors will form. So those 7 colors are formed on the screen, but still he want to split those colors. So that's why he sent over the another prism, placed it in a normal position. So besides of the first prism, so he didn't get anything. Same, all the seven colors came. So outside. So what he did, he placed inverted prism besides of the first prism, then he got white light. Okay, so instead of splitting, so those all 7 colors are merged again and came out as a white light ray. So you can see here, I'm taking now. Okay, done. So now, when the white light ray passes through the prism, split into 7 colors. Again, those 7 colors will form on another prism, placed in inverted position. So we'll get outcome as a white light ray. Outcome as a white light ray. So incident light ray is white light. outcome as also white light. So this is called recombination of spectrum white light. Recombination of spectra of white light. Recombination of spectrum of white light. Okay. Okay, so we are going to the next one. Rainbow formation by prism. Rainbow formation by prism and recombination of spectrum white light. Now, rainbow formation by water droplet. So this question will come for 3 marks. This question also will come for 3 marks. So make sure that you are practicing these two. Okay, right. So next rainbow formation by water droplet. So incident light ray, this is the incident light ray. So after that split into 7 colors. These are 7 colors. Okay. So after that you can observe. So this is red light and violet. So here you can see this rainbow formation. I'm taking this white light. White light, white light, white light, white light. Rainbow formation, rainbow formation. This is red light and violet, red and violet. This is rainbow formation by water droplet, rainbow formation by water drop, rainbow formation by water drop, and light ray passes through the when light ray passing through the water droplet, it acts as a tiny prism. Every rainbow drop acts as a tiny prism. When light passes through that prism, the light passes through the water droplet. It's split into 7 colors. Those are violet, indigo, blue, green, yellow, orange, red. Violet, indigo, blue, green, yellow, orange, red. Those 7 colors, refraction takes place next to dispersion. refraction, dispersion, internal reflection, refraction, dispersion, internal reflection, refraction, dispersion, internal reflection, refraction, dispersion, internal reflection. The phenomena involved in the formation of rainbow is refraction, refraction, dispersion, dispersion, refraction, dispersion, internal reflection, internal reflection, internal reflection, internal reflection, internal reflection, refraction, internal reflection, refraction, dispersion, internal reflection. When white light passes through water drop, it undergoes refraction, dispersion, internal reflection, refraction, dispersion, internal reflection, internal reflection, refraction, dispersion, internal reflection, refraction, dispersion, internal reflection. This is the phenomena involved in the formation of rainbow, involved in the formation of rainbow by water droplet, by water droplet. Next one, we are going to the one more condition, that is dun, 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 dun. So one more condition is atmospheric refraction. Refraction takes place by the atmosphere is called atmospheric refraction. Refraction takes place by the atmosphere is called atmospheric refraction. Atmospheric refraction. And here scattering of light, the re-emission of light in different directions with the different intensity is called scattering of light. Re-emission of light in different directions with the different intensity. Refraction of re-emission, re-emission of light, re-emission of light in different directions with a different intensity, re-emission. So when light ray comes from the sun, if you are taking any source, if the light ray is coming after incidenting, again it will be re-emission, a re-emission of light in different directions with a different intensity. Re-emission of light in different direction with a different intensity is called re-emission of light in different directions with a different intensity is called different intensity is called re-emission of light in different direction with a different intensity is called scattering of light, is called scattering of light. Okay, so now I will explain. I'm taking the wavelength, so I'm taking the wavelength, I'm considering this one. So this is the crust and trough, crust and trough, crust and trough. The distance between two consecutive crust is called wavelength. The distance between two consecutive crusts, two consecutive trough. This is the trough and this is the crust. So the distance between two consecutive crust and two consecutive trough is called wavelength, wavelength, wavelength lambda, wavelength lambda, wavelength lambda we are considering. So if the light ray is coming, so after incidenting on the particle, so if the particle size is comparable to the wavelength of the wavelength of the light. If the light what, so this is the particle, light is incidentting on it. This light wavelength is here. So wavelength and this particle is here. So the wavelength of the light is comparable to the particle size. Comparable to the particle size. Then the particle will absorb the light. Then the particle will absorb the light and re-emit. So re-emit in different directions with a different intensity. Re-emission of light in different directions with a different intensity is called. So re-emission of light in different directions with a different intensity is called re-emission of light in all directions also, because it's moving in all directions, right? In all directions. So re-emission of light in all directions, re-emission of light in all directions with a different intensity. Re-emission of light in all directions with a different intensity is called scattering of light. Sky appears blue color, sky appears reddish in the morning and evening, so blue color in the remaining time, white color noon time. Because so when in noon time, whenever light ray comes, when a light ray reaches from the sun, whatever the clouds are there, because of the clouds all the light will scatter equally in all directions. That's why all color will be mixed, all colors will be mixed, and we will see white light, we will see white light. Remaining time, the shorter wavelength scatter the most. Okay, so the shorter wavelength will scatter the most. That's why blue color so scatter the most. That is the reason then compared to the remaining colors. That's why sky appears blue color. Even deep sea also it appears blue color. It appears blue color. It appears blue color. So because of the scattering of light, because of the scattering of light. And atmospheric refraction, the sun appears above the origin, below the origin due to atmospheric refraction. Refraction takes place by the atmosphere. Refraction takes place by the atmosphere is called refraction takes place by the atmosphere is called atmospheric refraction. Refraction takes place by the atmosphere is called atmospheric refraction. Atmospheric refraction. Okay, so this is about atmospheric refraction. And Tyndall effect. The path of the light becomes visible when it is passing through the colloidal solution. The path of the light becomes visible when it is passing through the colloidal solution. Due to colloidal solution, scattering of light takes place. Due to colloidal solution, scattering of light takes place. That's why the path of the light becomes visible. The path of the light becomes visible. That is called Tyndall effect. 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 Is it clear? I hope it is clear. Next one. That's enough about human and colorful world. Eye parts and function, myopia, hypermetropia, presbyopia is nothing but the person can't able to see near distance as well as far distance. We are using bifocal lens. Upper portion is concave, lower portion is convex. And cataract, a milky and cloudy will form on eye lens. Okay, so by using laser surgery we can remove the defect, that is cataract. Coming to the astigmatism, so the person can't able to identify the horizontal lines as well as the vertical lines, horizontal lines as well as the vertical lines. So by using suitable cylindrical lens, we can correct the defect. We can correct the defect. That is about astigmatism. And coming to the one more, if the light ray passes through the prism split into 7 colors, the splitting of white light into 7 colors is dispersion. The band of colors will form on the screen. That is called spectrum. Spectrum. So the recombination of spectrum of white light, So when light ray passes through the prism split into 7 colors, again it will forms on the inverted position prism. So then we'll get outcome as a white light ray. So that is about recombination of spectrum of white light. When it is passing through the rainbow, if the light ray passing through the rainbow, so the phenomena involved in the formation of rainbow is refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. And coming to the atmospheric refraction, refraction takes place by the atmosphere is called atmospheric refraction. Because of atmospheric refraction, twinkling of stars. So star's position is here. So light rays keep on coming from that position. Light rays keep on from that position. Because of the atmosphere, there are so many refraction takes place. That's why stars appear twinkling. So why planets do not twinkle? Because So planets are minute sources of light. So minute sources of light means so one place it will be dark, one place it will be bright like this. So it reflect the light. So planet doesn't give their own light, but it reflect the light. So it at one place it will be brighter, one place it will be darker. So that's why entire effect will be nullified. That is about a star twinkle, why planets do not twinkle. So that is very very important 3 marks question. And next one we are going to the one more topic, that is scattering of light, the re-emission of light in different directions with the different re-emission of light in all directions. Once again remember this point, re-emission of light in all directions with a different intensity is called scattering of light. Scattering of light, scattering of light. Tyndall effect. Next, Tyndall effect, the path of the light becomes visible when it is passing through the colloidal solution. The path of the light becomes visible when it is passing through the colloidal solution. Colloidal solution. Colloidal solution. So by the colloidal solution, scattering of light takes place. That's why we can able to see the path of the light becomes visible. Yes or no? That's enough. That is about concept. I hope we covered all the topics. Yes. So thank you so much. Thank you so much for joining and listening my class. So thank you so much. So thank you for giving an opportunity to talk and express my ideas at the same time to teach. Thank you so much for joining and listening. So I'm grateful for you all. Thank you so much. See you soon.